So the next question that we have here is another developments question. It says question 2, a cardboard magazine display unit is shown on the left. So we can see that over here in this section right here. Draw the plan of the display unit, complete a one-piece surface development of the container, thickness and the internal partitions can be ignored for the drawing. So what that essentially means is we have the elevation and end elevation given to us. We have to construct a plan from what we are given, quite easy to do, and then we also have to do a surface development of it. And when we break down the surface development, obviously we have to work out then, it says we can leave out the internal structures inside in here for obviously separating the magazines on the shelf, and there is no thickness added in either. So obviously we'll leave out this little bit here, but I'd imagine we'll have to do the DCG part as well. So we'll crack on with that there now. So starting off with the plan, we have to elevation here, end elevation here, construct a plan view down here. So you should have no problem with this, so just going to crack on with it. So from the corner of the plan, or from the corner of the elevation, 45-degree line. So now what I'm actually going to do is I'm going to take cuts on this section here to generate the curve, because we can see the curve, even though we've got a curve on this side, we've also got a curve on this side as well. However, on this side it's actually on a sloped surface. So to be able to get that curve down here, it's going to end up looking something like that. I'm going to basically take cuts. This one here, obviously I just see it as a line because I'm looking straight down it. However, on this side I'm going to have to take cuts. I'm going to take a series of cuts. I'm going to take them at regular intervals. 1, 2, 3. So the first one there, cuts here, hits here. Cuts, hits here. Cuts, hits here. And where it hits all those 3 places, I'm going to drop them down. Not sure exactly how far I just need them yet. So most of them the whole way down. And where it hits these 3 places, drop them down to my 45-degree angle. Where they're here, drop them across. Further down and locate my points. So if I was to use numbers, I'll call this 1, 2, 3, 4, 5. Got 1, 2, 3, 4, 5. So 1 is here, 5 is already here. Now I want to find 2, 3, 4. Do it with a pencil first. Plan done. Nice and easy, nice and simple. So, next part of this question, it says we have to do the complete surface development of this whole structure here, excluding the internal parts inside and here for obviously the magazines to separate them out. So if we break it down, we want to see how many sides we have, how many whatever front we have, and so on. So breaking it down, we have a back, we have obviously got a base, the base comes out to the front, then we got a side, and we have a side, and then we also have this bit here as well, this bit right here at the front where it says DCG, and that falls down, so that's obviously connected onto it as well. And it tells us to disregard the thickness in the question as well, so we're not going to obviously have this bit inside in here that's folded out extra as well. It's just going to be a back, a bottom, a front, a side, and this bit here that connects down as well. So to be able to do that, the easiest part we can actually start with straight away is probably the back, because the back is going to take the same shape as our elevation right here. It's just a case of being able to fit it in on our sheet accurately. So, moving across there, what I would do is I would take the dimensions straight from the elevation for the base, because that is a true length right there. Pick a start point. I'm just thinking, I'm going to take it about here. And right there, that is going to be my length of my base. Now, that base goes up a certain height. And then it also has a certain length at the top of it. That is the back part of the problem. Next part I'm going to focus on is going to be the base. And the base, obviously we already have a dimension here. It's just a case of figuring out how far it's going to come out. As it's folded out, fold it down. And it's a case of working out that dimension, and we can get that dimension, the width, from down here, this distance from here to here. Once again, take that on my compass. And I can step that down. There's the bottom. Now, I'm going to focus on the first side, which is this side over here in this section, and that side is actually just going to be the exact same as this image here, only if you imagine it's going to be flipped over, like axial symmetry. So straight away there, I can actually take some measurements on it. So for 1, I know it's going to come out this far from here to here, which is the distance of 1 out. So I'll take this distance, that's my first measurement out, do it on the side here. And that is going to come up a certain height. And that is going to go up as far as this guy here. Now, that's for height 1. For 2, for 3, for 4, for 5, we already have this one here because that's where it's going to join onto, but I have to get the ones in between. So for 2, it's just a case of bringing it across. Same with 3, or wherever how you index it yourself. And 4. So now just take those distances on my compass because they are all true lengths. Take the distance for 2, from there to there. Step it off. Same for 3. Step it off. Same for 4. Step it off. And what I would do then, freehand curve. So that's the first side. Now I'll get on to the next side, which is going to be over here. Now this one is a little bit different. It's not going to come straight off here. If you imagine, it's going to be attached onto the side, so it's actually going to come off this perpendicular to this line. So what we need to do is a bit of sliding set squares here, just to get our perpendicular angle. So, line up your 45 on it, the line that we want. Now, from the base, it's going to step out perpendicular. The same as it did here. This was one if we imagine a while ago. It's going to be perpendicular. Same with 2. It's going to be the exact same shape, just at an angle. So the exact same thing as we did on the opposite side, only at an angle. So, same distance out for 1, here and here. Same distance for 2. Three, 4, and obviously 5 is at the top. So I'll do my curve first. This portion of it here is a straight line. That is my other side. Now what I'm going to actually do is, just to make it a little bit clearer, to make it stand out a little bit further, we'll give it a little bit of a finish. Okay, just use a little bit of labels there actually as well, just to say that's 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Okay, now the next part is this DCG symbol that comes down here, which is going to be along this way if we imagine it. That's coming down here. If I just, for the all intents and purposes, so you can understand, there will be the D, the C, the G, DCG going down. Now essentially what's going to happen is that bit there is just going to lift off, and what we have to do is just have to work out where that is. First of all, I won't be able to take this distance on my compass, but I'm just going to measure that, and it's working out on my set square to be 7, so that distance from there to there is 7. So let's go at how far I'm going to step out here. That means I can heavy in as far as here, and in here is where it's going to fold off, and it's going to fold up here. We just have to work out that length. Now, to be able to do that, line up, it's going to fold up straight, line up, we just have to get the length. And like we do, you can't obviously measure a curve over here, we can't measure that distance obviously with a ruler. So what we do is we take the distances in between our various cuts. So, starting with 5, 5 is going to go back to 4, which is here, 4 to 3, because I did random cuts, they're not all the same length, 3 to 2, and 2 down to 1. So label them 5, 4, 3, 2, 1. So if that was to fold down, obviously 4 matches to 4, 3, 2, 1. Now I can heavy that in. Couple of little bend lines in between. There you go. And the last little bit that we have now is just here at the front. So it is. And our front, we actually have a true shape of it here already. Okay, which is this thing here. We have the true shape of that already. So on top of that front, we're actually going to have, I forgot to put it in here, another fold line. And the front is going to come off of this. However, that front, it's not going to be a perfect rectangle. It's actually going to be this guy here where he's cut a little bit over here. So that cut is going to happen on this side. And it's going to come inwards like that. It's just a case of working out the lengths for it. So once again, nearly there now. What I can do is take this down, and I can see where the original cut was. Would have been there. It's going to be down there somewhere. And what I can do is take this distance from here to here, because that is the true length of it, of the height of it, of the front, and measure that off. Quite simply, there we go. That then joins up to here. That is the front. Just heavy that in. Question done.